Good morning to all. I am Subarani, Associate Professor in Emmanuel College of Pharmacy. Today's topic is a heterocyclic compound of thiazole. First of all, synthesis of thiazole. So, the preparation of thiazole. First method is by the interaction of thioamides and alpha halocarbonyl compounds. Thioamide and alpha halocarbonyl compound. Chloroacetone is reacted with thioacetamide. Chloroacetone is reacted with thioacetamide to form 2,4-dimethylthiazole. A derivative of thiazole is obtained. 2,4-dimethylthiazole. Second position and fourth position, a methyl group is obtained. So, from 2,4-dimethylthiazole is obtained. Then second preparation is by the interaction of chloroacetaldehyde and thioformamide. Chloroacetaldehyde CH2Cl chloroacetaldehyde is reacted with thioformamide. S double bond CH single bond engaged to thioformamide. So, thiazole is obtained. Okay, thiazole is obtained. So, the two preparation, first one is interaction of thioamides and alpha halocarbonyl compound. Thioamide means thioacetamide is reacted with the chloroacetone to form a product 2,4-dimethylthiazole is obtained. Then second preparation is chloroacetaldehyde and thioformamide. Chloroacetaldehyde is reacted with the thioformamide to form thiazole is obtained. Okay. Then third preparation is by the interaction of thiourea and alpha halocarbonyl compounds. Third preparation of thiazole is interaction of thiourea and alpha halocarbonyl compound. Alpha halocarbonyl compound is chloroacetaldehyde CH2Cl chloroacetaldehyde is reacted with thiourea. Chloroacetaldehyde is reacted with thiourea. 1 molecule of water and 1 molecule of hydrochloric acid is removed to form 2-aminothiazole. Second position is amine group, engaged group is obtained. So, 2-aminothiazole is formed. Then it is reacted with sodium nitrate NaNO2. Thiazole diazonium chloride is formed. Thiazole diazonium chloride is formed. It is reacted with ethanol. It is boiled with ethanol to form thiazole. So, thiazole is obtained in alpha halocarbonyl compound and thiourea. First of all, chloroacetaldehyde is reacted with thiourea to form a product 2-aminothiazole. 2-aminothiazole is obtained. It is reacted with sodium nitrate NaNO2 and hydrochloric acid to form a product. Thiazole diazonium chloride is obtained. It is reacted with ethanol. It is boiled with it is heated with ethanol to form a product. Thiazole is obtained. Okay. Then fourth preparation is 2 mercaptothiazoles. 2 mercaptothiazoles can be prepared by the reaction of ammonium dithiocarbamate and alpha halocarbonyl compound. Alpha halocarbonyl compound and dithiocarbamate. Alpha halocarbonyl compound and dithiocarbamate is reacted to form a product. So, the derivative of thiazole is obtained. Okay. So, these are the four preparation of thiazole. First one is derivative of 2,4-dimethylthiazole is obtained. So, chloroacetone is reacted with thioacetamide to form a derivative of thiazole. Then second method is chloroacetaldehyde is reacted with thioformamide to form thiazole. Then third method is thiourea is reacted with alpha halocarbonyl compound. So chloroacetaldehyde is reacted with thiourea. First form a product 2-aminothiazole. Then it is reacted with sodium nitrate to form thiazole. Diazonium chloride is obtained. Then it is further boiled with ethanol to form thiazole. Then fourth method is 2 mercaptothiazoles can be prepared. 2 mercaptothiazoles can be prepared. Ammonium dithiocarbamate and 6 and alpha halocarbonyl compound to form a 2 mercaptothiazoles. 2 mercaptothiazoles is obtained. Then characteristics reactions of thiazoles or chemical reactions of thiazole. First of all, electrophilic substitution. The reactivity is intermediate between pyridine and thiophene, but it is less reactive than imidazole. The reactivity is intermediate between the electrophilic substitution reaction is intermediate between pyridine and thiophene. Intermediate level of pyridine and thiophene, but it is less reactive than imidazole. So electrophilic substitution reaction is less than imidazole of thiazole. Okay, the electrophilic attack preferably takes place at position 5 only. Okay, the electrophilic substitution reaction is must prefer in the position is 5. Okay, in acid media the attack usually takes place through the formation of thiazolium cation. In acid media, the attack is usually takes place through the formation of thiazolium cation. Okay, so electrophilic substitution reaction, the reactivity of intermediate between pyridine and thiophene, and it is less than the reactivity of imidazole. So electrophilic attack preferably take place in 5th position. So in acid media, the attack usually takes place through the formation of thiazolium cation. Okay. Then first electrophilic substitution reaction is nitration. Under vigorous condition, nitration by means a mixture of concentrated nitric acid and sulfuric acid takes place. Concentrated nitric acid and concentrated sulfuric acid takes place in nitration reaction. Thiazole is reacted with the sulfuric acid, concentrated sulfuric acid and concentrated nitric acid to form 5-nitrothiazole is obtained. So the electrophilic substitution is preferably attacked in 5th position. So only nitro group is attached in 5th position. So 5-nitrothiazole is obtained. Okay. Then second reaction is sulfonation. Under vigorous condition, sulfonated by means of sulfuric acid and oleum. Thiazole is reacted with sulfuric acid H2SO4 and oleum to form thiazole 5-sulfonic acid is obtained. In 5th position, substitution takes place. So thiazole 5-sulfonic acid is obtained. The next one is chlorination. 2-chlorothiazole can be obtained by treating 2-thiazolone with phosphorus pentachloride. 2-thiazolone is reacted with the phosphorus pentachloride to form 2-chlorothiazole. Okay. In electrophilic substitution reaction, mainly first of all nitration, thiazole is reacted with the concentrated sulfuric acid and concentrated nitric acid. So a product 5-nitrothiazole is obtained. Then second one is sulfonation. In vigorous condition, thiazole is reacted with the concentrated sulfuric acid and concentrated nitric acid. Thiazole 5-sulfonic acid is obtained. Then chlorination and 2-chlorothiazole can be obtained. So 2-thiazolone is reacted with phosphorus pentachloride to form 2-chlorothiazole is obtained. The next reaction is bromination. Thiazole itself resistant to bromination. However, if electron donating groups are present, then bromination is achieved. Thiazole itself resistant in bromination. However, electron donating groups are present, then bromination is achieved. Okay. 2-hydroxythiazole is reacted with chloroform CHCl3 and bromine to form 5-bromo 2-hydroxythiazole is obtained. 5-bromo 2-hydroxythiazole is obtained. Thiazole can be brominated directly in the gas phase, gives 2-bromothiazoles. Okay, thiazole is reacted with the gas phase to form 2-bromothiazole. So bromination is obtained in two forms. First, the thiazole itself resistant to bromination. However, the electron donating group is present, then bromination is achieved. 2-hydroxythiazole. 2-hydroxythiazole is reacted with bromine and chloroform to form 5-bromo 2-hydroxythiazole is obtained. Then thiazole can be brominated directly in the gas phase. Thiazole is reacted with the bromine to form 2-bromothiazole is obtained. 2-bromothiazole is obtained. Then hydrogenation. Then second reaction is hydrogenation. Thiazole is resistant to hydrogenation, but some substituted thiazoles undergo ring cleavage by means of sodium and ethanol. Thiazole is resistant to hydrogenation. Okay, thiazole is resistant to hydrogen, but some substituted thiazoles undergo ring cleavages by means of sodium and ethanol. So 4-methyl-5-phenyl thiazole. 4-methyl-5-phenyl thiazole. The presence of sodium and ethanol NaC2H5OH to form a product is obtained. Okay, ring cleavage product is obtained. Diazotization. Thiazoles react with sodamide to form 2-aminothiazole which undergoes diacetation. Thiazole reacts with sodamide to form 2-aminothiazole which undergoes diacetation. Thiazole reacts with sodamide NaNH2 to form 2-aminothiazole which undergoes diacetation. Thiazole is reacted with sodamide to form 2-aminothiazole. The thiazole 2-aminothiazole is further diacetation. Okay, hydrochloric acid and HONO to form diazonium chloride. Diazonium chloride. Okay, so hydrogenation and diacetation is study. Then condensation with benzaldehyde. 2-methyl-thiazole condenses readily with benzaldehyde in the presence of algae. 2-methyl-thiazole is reacted with or condensed with benzaldehyde in the presence of alkali. 2-methyl-thiazole is reacted with benzaldehyde in the presence of alkali to form a product 2-phenyl-vinyl-thiazole. 2-phenyl-vinyl-thiazole is obtained. Then reaction with nucleophiles. Thiazole is susceptible for nucleophilic attack at position 2. Thiazole is susceptible for nucleophilic attack at position 2. Then reaction of potassium amide in liquid ammonia with thiazole affords 2-amino-thiazole. 2-amino-thiazole. Thiazole is reacted with liquid ammonia and potassium amide. Potassium amide. KNH to potassium amide and liquid ammonia to form 2-amino-thiazole. 2-amino-thiazole is obtained. Then reaction with N-alkyl lithium. Reaction with N-alkyl lithium. N-butyl lithium thiazole is methylated at second position. Second position. N-butyl lithium CH3 CH2 CH2 CH2U. N-butyl lithium is reacted with thiazole to form a product. Thiazole 2-lithium. Thiazole 2-lithium is obtained. Then oxidation and reduction of thiazole. Thiazole ring is resistant to oxidation by nitric acid, but the ring is opened by potassium permanganate. Thiazole ring is resistant to oxidation by nitric acid, but the ring is opened by potassium permanganate. Thiazole ring is also resistant to the action of many reducing agents, although ranine nickel can be used for desulfurization reaction. Okay, oxidation and reduction reaction. Thiazole ring is resistant to oxidation by nitric acid, but the ring is opened with the potassium permanganate. Then thiazole ring is also resistant to the action of many reducing agents, although ranine nickel can be used for desulfurization reaction. So 4-phenyl thiazole. Hydrogen nickel and ethanol to form 1-phenyl ethylamine. 1-phenyl ethylamine is obtained. So these are the chemical reaction. First one is electrophilic substitution reaction. First reaction is nitration. Thiazole is nitrated. Concentrate HNO3 and nitric acid to form 5-nitrothiazole. Then sulfonation. Under vigorous condition, sulfonated by means of sulfuric acid and oleum. So thiazole is reacted with the sulfuric acid H2SO4 and oleum to form thiazole 5-sulfonic acid. Then chlorination. 2-chlorothiazole can be obtained by treating thiazolone to thiazolone with the phosphorus pentachloride to form 2-chlorothiazole. Then bromination. Thiazole itself resistant bromination. So 2-hydroxythiazole bromine with CHCl3 chloroform to form 5-bromo 2-hydroxythiazole. And then thiazole can be brominated directly in the gas phase. Thiazole is in gas phase to form 2-bromothiazole is obtained. Then hydrogenation reaction. 4-methyl 1-phenyl thiazole is treated with sodium and ethanol to form a substituted thiazole is obtained. Then diacetization. Thiazole reacts with sodamide. Thiazole is reacted with any and sodamide to form 2-nitrothiazole, which undergo diacetation to form thiazolyl diazonium chloride. Thiazole reacts with sodamide to form 2-aminothiazole, It is further undergoes diacetation to form thiazole-diazonium chloride is obtained. Then condensation with the benzaldehyde reaction. 2-methyl-thiazole is reacted with the benzaldehyde to form 2,2-phenyl vinyl thiazole is obtained. Then reaction with the nucleophiles. Nucleophilic attack position is second position. So thiazole is reacted with the potassium amide and liquid nitrogen to form liquid ammonia to form 2-aminothiazole is obtained. Then the reaction with the N-alkyl lithium to form a product. Thiazole 2 lithium is obtained. Oxidation and reduction reaction. Then the oxidation is resistant by nitric acid, but the ring is reacted with the permanganate. Then thiazole ring is also resistant to the action of many reducing agent. Although radionickel is can be used for disulfurization reaction. 4-phenyl-thiazole is reacted with ethanol to form 1-phenylethylamine. 1-phenylethylamine is obtained. Then medicinal uses of thiazole. First of all, troglitazone. Troglitazone is used to treat non-insulin dependent diabetes mellitus. So type 2 diabetes, non-insulin dependent diabetes mellitus. Along with the diet and exercise and insulin, a sulfonylurea or metformin is necessary. Okay. Troglitazone. Troglitazone is to treat non-insulin dependent diabetes mellitus. Along with the diet and exercise and insulin, a sulfonylurea or metformin if necessary. So this is the structure of troglitazone. Troglitazone. Then next one is rosiglitazone. Rosiglitazone is indicated as an adjunct to diet and exercise to maintain glycemic control in type 2 diabetes. Okay, rosiglitazone. Rosiglitazone is indicated as an adjacent to diet and exercise to maintain the glycemic control in type 2 diabetes. Rosiglitazone. This is the structure of rosiglitazone. Pioglitazone. Pioglitazone is used adjunctively with the diet and exercise to normalize glycemic levels in adults with type 2 diabetes mellitus. Okay, pioglitazone is used adjunctively with the diet and exercise in normalized glycemic levels in adults with the type 2 diabetes mellitus. Okay, this is the structure of pioglitazone. Pioglitazone. Next one is famotidine. Famotidine is a histamine H2 receptor antagonist used to treat duodenal ulcer, benign gastric ulcer, gastroesophageal reflux disease and Zollinger-Ellison syndrome. Okay. Famotidine is a histamine H2 receptor antagonist. It is used an antagonist to treat the duodenal ulcer, benign gastric ulcer, so gastroesophageal reflux disease and Zollinger-Ellison syndrome. This is the structure of famotidine. Sulfathiazole. Sulfathiazole is effective against a wide range of gram-positive and gram-negative pathogenic microorganisms. Sulfathiazole is an effective against a wide range of gram-positive and gram-negative pathogenic microorganism. Okay, this is the structure of sulfathiazole. Pathylyl sulfathiazole. Pathylyl sulfathiazole is a broad spectrum intermediate spectrum antimicrobial agent. It is used in the treatment of dysentery, colitis, and gastroenteritis. Pathylyl sulfathiazole. Pathylyl sulfathiazole is an antimicrobial agent. It is used for treatment of dysentery, colitis, and gastroenteritis. This is the structure of pathylyl sulfathiazole. Pathylyl sulfathiazole. Next one is meloxicam. Meloxicam is an NSAID used to treat osteoarthritis in adults, rheumatoid arthritis in adults, and juvenile rheumatoid arthritis in pediatrics. Okay, meloxicam is used to osteoarthritis in adults and rheumatoid arthritis in adults. Okay, this is the structure of meloxicam. Thiabendazole is an antihelminthic medication. Thiabendazole is used as an antihelminthic medication. It prevents worms from growing or multiplying in the body. Thiabendazole is used to treat infections caused by worms such as threadworm. So this is the structure of thiabendazole. So these are the notes for thiazole. Okay, thiazole, synthesis of thiazole, then characteristic reactions of thiazoles, substitution reaction, electrophilic substitution reaction, and medicinal uses of thiazoles. Okay, thank you, students.